Hello, my name is Cesar Santana,
I'm Zilan.
and our model focused on the relationship between morphine and blood pressure. Our question was, how does the amount of morphine injected intravenously affect blood pressure level? And in order to answer this question, we decided to create a model with three stocks. These three stocks being morphine, histamine, and adrenaline. Morphine would be injected intravenously and would decrease at a rate proportional to the amount of morphine in the body. Morphine would then cause the secretion of histamine and adrenaline in the system, which would then leave the body at a rate proportional to the amount of histamine and adrenaline in the body. And here we have our three differential equations, which model the three stocks that we have here. We also have a fourth equation, which is the blood pressure equation. This one shows this depends on the amount of histamine and adrenaline in the body, and also given initial blood pressure level.
After then, we implement our mathematical models into MATLAB and compared our model with the real data. We put our concentration of morphine and histamine into a log scale so that we can compare them with the data more accurately. In those two graphs, as you can see, they matches with the data really well. And our third graph here is the comparison between the real data of the fluctuation of blood pressure after the injection of 20 milligrams of morphine with our model. And in those two graphs, in the real data, they have an assumption that our blood pressure remains constant at 80 BP. And in our model, we start to measure the blood pressure after the injection of morphine. So we should compare those two graphs from here and here. And in the end of the graphs, the real data returns to an equilibrium about 75 BP, while in our model, returns to an equilibrium about 80 BP. But they are all in the safety range of human blood pressure, so I think our model works pretty good. But there are indeed some limitations of our model. First of all, we only include like 3 stocks in our model, but there are like countless substances that have an effect on the blood pressure. But due to the limitation of time and resources, we choose only use these 3 models to represent the blood pressure. Also, we neglect the interaction between histamine and adrenaline. The interaction isn't that big compared to their direct effect on blood pressure.
For our results, we graphed different amounts of morphine and their effect on blood pressure. We saw that small doses of morphine generally cause a small change in blood pressure. But as we increase the amount of morphine injected, we see that the level of blood pressure goes to higher extremes and as well as lower extremes. In this area here, we see that there's an initial increase in blood pressure. This initial increase is due to the adrenaline in the body at this moment. And then we see it's followed by a decrease in blood pressure, which is caused by the histamine. The reason we see the increase first is because adrenaline has a faster growth rate, but it also has a faster decay rate. Histamine, on the other hand, has a slower growth rate, but a slower decay rate, which is why initially we see a higher blood pressure, but over time we see that the histamine has a greater effect, and that is what causes the blood pressure to lower given more time. Our second graph for results shows the graph's morphine amount versus the blood pressure level. So here we see the peak blood pressure, and here we see the trough blood pressure. And as we can see, the higher amount of morphine you have, the greater the peak and the trough. The greater the peak is for blood pressure, and the lower the trough is for blood pressure. We can see that passing the 10 milligram mark for morphine, blood pressure begins to rise a bit above what is considered the healthy range for blood pressure. And so that could be potentially dangerous, but where it is actually really dangerous is passing the 30 mark for morphine. Because here we see that not only does it reach levels that are too high initially, but it also continues to decrease into levels that are dangerously low for blood pressure. So we can see that passing the 30 milligram mark with morphine is when we get to the dangerous levels for blood pressure change.
Well, in the future, we're going to include more stocks into our model to represent the blood pressure more accurately, and we're going to take into consideration of the interaction between adrenaline and histamine. But I think our model with only 3 stocks can represent the general trend of fluctuation of blood pressure pretty well, and it answers the question in a simple and efficient way. So our model did a good job.